Today we're going to talk about ocean currents. Ocean currents. Okay? An ocean, what you need to know is it's a lot like the atmosphere. The atmosphere has air masses moving and bumping into each other and rising and all that stuff. Well, ocean water is the same way. Ocean water is not just sitting still. It's not like a pool that no one's in. Okay? There is movement for various reasons, for the wind, or just natural currents, or density issues, different hot, warm and cold water moving. Okay, there's tons and tons of movement in the ocean. Write this down. There are two types of ocean currents. Two types of ocean currents. The first one, surface currents, and I would write this down. If I'm going too fast, you can always pause. Surface currents affect the top 300 feet of the ocean. So it's the top layer of the ocean. Most are caused by wind, the rotation of Earth, and the presence of continents, called the Coriolis effect. So surface currents are the top part. If you look at this, I don't know how well you can see it, but you notice here's the equator right here. Okay? Most ocean currents north of the equator are going to move clockwise. Okay, you see this? Clockwise. Makes sense here. Here's like Florida. Okay, most of our hurricanes start right here, and they get brought up this way. Okay, so clockwise like this. Here's the equator again. Most currents south of the equator move counterclockwise. Okay, they basically follow the coast there. That's called the Coriolis effect. So northern hemisphere is clockwise, southern hemisphere counterclockwise. The second kind of current is called a density current. Second type of current is density current. This is going to affect everything lower than 300 feet. So not just the surface, but deep below. The wind has nothing to do with this. A lot of these density currents are caused by differences of density. Okay, I would probably put this down. Cold water is more dense than warm water, so cold water is going to sink. Saltier water is also more dense than not as salty water, so it's going to sink. So the deeper you go in the ocean, the colder the water is going to be, and the saltier the water is going to be. Now you might say, okay, well, duh, the ocean, the bottom of the ocean is going to be cold because there's no sun. Well, there are volcanic vents that also heat up water. So if we have volcanic vents heating up water, that water is going to rise up to the surface, and the cold stuff will fall. So density currents, it's all about the differences of density. Cold things like cold water is more dense, so it's going to sink. Warm is less dense, so it's going to rise. Saltier water is more dense, so it's going to sink. So all of those have to do with density. There's another term here, upwelling, movement of cold water upward. What happens is you get a wind. If this is the coast area here, you get a wind that pushes off the top layer of water. It moves it, and then you have cold water following the coast up to the surface. Movement of cold water upward. Upwellings are usually excellent fishing areas because when the water moves upward, it brings fish with it. Fish don't realize that they're in the current, and they get carried to the surface where you can catch them. There's a couple, I think there's another thing I wanted to talk about here. Okay, you've probably heard of a couple things like Iceland and Greenland. There's Iceland, there's Greenland. Okay, you've maybe heard of kind of the history of that. I forget which country it was. When they discovered Iceland, they named it Iceland because it was a really nice place and they wanted people to stay away from it. Okay, Iceland, you might think, well, wow, look how north that is. That's got to be really cold. Well, if you get water rotating like this, you get warm water from near the equator rotating towards you, it's really not going to be so bad. So Iceland is actually fairly pleasant weather due to the warm water around it. Kind of what we just said. Don't write anything. How do currents affect ocean life? There are a bunch of animals that rely on currents. Okay, things like plankton and krill and jellyfish. They can't really swim on their own. They need the currents to move them.